A stellarator is a device used to confine hot plasma with magnetic fields in order to sustain a controlled nuclear fusion reaction. The name refers to the possibility of harnessing the power source of the Sun, a stellar object. It is one of the earliest fusion power devices, along with the Z-pinch and magnetic mirror. The stellarator was invented by Lyman Spitzer of Princeton University in 1951, and much of its early development was carried out by his team at what became the Princeton Plasma Physics Laboratory. The basic concept is to lay out the magnetic fields so that particles circulating around the long axis of the machine follow twisting paths, which cancels out instabilities seen in purely toroidal machines. This would keep the fuel confined long enough to allow it to be heated to the point where fusion would take place. The first Model A started operation in 1953 and proved the basic layout worked. Larger models followed, but these demonstrated poor performance, suffering from a problem known as pump out that caused them to lose plasma at rates far worse than theoretical predictions. By the early 1960s, any hope of quickly producing a commercial machine faded, and attention turned to studying the fundamental theory of high-energy plasmas. By the mid-1960s, Spitzer was convinced that the stellarator was matching the Bohm diffusion rate, which suggested it would never be a practical fusion device. The release of information on the USSR's tokamak design in 1968 indicated a leap in performance. This led to the Model C stellarator being converted to the symmetrical tokamak as a way to confirm or deny these results. Saint confirmed them, and large-scale work on the stellarator concept ended as the tokamak got most of the attention. The tokamak ultimately proved to have similar problems to the stellarators, but for different reasons. Since the 1990s, this has led to renewed interest in the stellarator design. New methods of construction have increased the quality and power of the magnetic fields, improving performance. A number of new devices have been built to test these concepts. Major examples include Wendelstein 7X in Germany, the Helically Symmetric Experiment in the USA, and the Large Helical Device in Japan.